Hey, welcome to video 18-3B. In this video we're going to be working with cones still, but we're going to be using some different formulas to find composite figures. So here I'm on Explain 2. This is page 953 at the top. And in example 2 here, we're trying to find the volume of the composite figure that we have below. So we're rounding it to the nearest cubic millimeter, and we can see some dimensions that were given to begin with. Again, our 16 millimeters, guys, is pointing at the center of the base of that cylinder, so we can assume that that right there is the diameter. And so as we use our calculations for cylinder and for cone, we need to make sure we are converting that to figuring out what the radius is first. So as we walk through here, find the volume of the cylinder first. We're going to find the radius by taking half of 16, and of course that's 8. So volume of the cylinder is pi r squared h. Remember, area of the base is the circle part of that. So pi r squared h is pi times 8 squared times 19 is the height of just the cylinder. So that is going to be 3,820.176 and so on millimeters cubed. So that's the first part of our composite volume. Then we need to find the volume of the cone. So just be aware of the dimensions that you see here. What we are given is that this height from the top or the apex of the cone all the way down to the bottom of the composite solid is 32. So we have to first figure out what is the height of just the cone right here. Well, that's going to be 32. Take away the 19 that we already have. And so we get a height of 13 millimeters. Now you can see that the cone fully takes up the top of the cylinder, so that means the radius is the same as the cylinder that we had before, which was 8. So we're going to plug it into the volume for a cone formula, which remember is 1/3 the area of the base times the height, or pi r squared times the height. So 1/3 pi, radius is 8 squared, times, remember, the height of the cone that we just calculated was 13. And that is going to give us 871.268 millimeters cubed as we look at our calculations there. So if we want to find the total volume, all we have to do is to put those two pieces together. So we're taking 3,820.177 if we round millimeters cubed, plus what we just found for the cone, 871.268 cubic millimeters, and our total rounded to the nearest cubic millimeter is going to be 4,691. So that's our composite example. Let's see what you guys can do with, on the next page, the your turn example. This time we are taking and making a cone-shaped hole in the top of a cylinder. And so instead of adding the cone and the cylinder, we of course want to subtract the cone's volume from the cylinder for this type of composite. And we're going to go back and forth between putting shapes together and adding and subtracting. So it's good that you have experience with both of these. See what you guys can do with your turn 6 and 7, and I'll see you tomorrow.